Good morning. Now you might think this is quite an odd question because we've got several ways now of solving quadratic equations, not least of course the calculators that I keep telling you you are perfectly okay to use now. So why throw this into the mix? Well, it's something that's on the syllabus, largely historical, but there are ways around the calculator which mean that using this method is important. And in particular, it is this method that we use to prove the quadratic equation formula. And proof is an important part of A-level. So I'm going to do this question. I'm going to start by completing the square for that quadratic. So shovel my 10 out there. I know that to make x squared plus 8x, I need an x plus 4 squared. But when I grid that out, that will also give me a plus 16 that I don't want. So I get this. So what I can now say is that this equation is the same as this equation. And what I'm going to do now is solve it just like I solve normal linear equations by balancing. Whatever I do to one side, I'm going to do to the other side. So I'm going to start by adding 6 to both sides. I'm then going to square root both sides, remembering that the square root of 6 is plus or minus root 6, and that's not a nice value, so I'm going to leave it as a surd. And I'm then going to take away 4 from both sides. And because it would look a bit odd having plus or minus root 6 take away 4, I'm going to write the minus 4 at the beginning. And those are my solutions. One solution is minus 4 plus the square root of 6, and one solution is minus 4 minus the square root of 6. Now, if I go to my calculator and I go to equation mode and select polynomial and 2, and I enter that in 1, 8 and 10, and ask it for the solutions, there they are, look, minus 4 plus the square root of 6 and minus 4 minus the square root of 6. So the calculator and I agree. And solving an equation by completing the square is a perfectly valid method of doing it. So we've got factorising, we've got using the formula, we've got using our calculator, we've now got the additional method of completing the square. Okay, so here's a second one. Why don't you have a go at this one, pause the video, and then we'll have a look at our answers in just a moment. Okay, so completing the square firstly. I hope that this is pretty automatic for you now. And if I was sketching y equals that would tell me that the turning point was there. But of course we're not doing that today, are we? We're not working out the turning point. We are solving this equation. So this is the same as this. So I can rewrite my equation as and now the order of these next few steps is crucial, is important. It won't work if we don't do it in the right order. So I've got to deal with that minus 8 first. Then I'm going to square root both sides. And then I'm going to take away 3 from both sides, and I'm going to choose to write that in front of the square root. Could write it afterwards, but that looks a little bit more like I'm used to seeing. So again, I've got 2 solutions, 2 roots to this equation. It's interesting to ask ourselves whether these solutions are positive or negative. Hopefully you agree that minus 3 minus the square root of 8 is negative. But minus 3 plus the square root of 8, well, is the square root of 8 big enough to pull minus 3 up into positive numbers? Well, it isn't, is it? The square root of 8 is smaller than the square root of 9. The square root of 9 is 3. So minus 3 plus the square root of 8 will still be negative, just negative. Interesting to note that if that had been a plus 8, so if this here had been plus 17, and this had therefore been a plus 8, this process wouldn't have worked because your first step would have been taking away 8, and you can't square root minus 8. And that's usual, isn't it? We're used to quadratic equations sometimes not having solutions. So completing the square gives you a really quick way of spotting whether or not you've got an equation without a solution. As long as you've got a negative value there, you know you're going to be able to solve it. And I can now sketch this quadratic if this was a y equals function, because I've got all of the elements I need. So I know it's happy. I know it crosses the y-axis at 1. I know its turning point is at -3, -8. And I know it's got two roots, two solutions, which remember these are the places where it crosses the x-axis. Both negative, although the -3 plus the square root of 8 is just negative, so something like that. So we can sketch our quadratic function. If a question says solve, you're not expected to do that, but I'm just trying to link it all together. Okay, so here we are on page 24 of the online textbook. Well done to that honest student who, even though I sent out the details late April as to how to get on, sent me an email yesterday admitting that they couldn't get onto the Active Teach textbook. So well done to you for your honesty. You know who you are. Virtual Bourbon biscuit for you. But please, if you are too embarrassed to say that you haven't actually ever got onto the online textbook, please tell me now, because it's absolutely essential. Most of you I know are on because you've been sending me work from it. So this is page 24, and we have just done question 1A. So you may choose to have a go now at 1B, 1C, and 1D. Don't forget the solution bank has got the answers. 1D, you've got to rearrange it first because you always need to have a 0. You might find those a bit easy, so you might decide, having done perhaps 1B, to have a go at 2A, which has more than 1x squared. Or maybe some of the even harder ones there, including 2D, which has got a minus x squared. Now the process for those is very similar. You've just got an extra step to do before square rooting. And I am going to do a work solution for 2A and just post it as an image with this homework or on class charts or with the email I send you, just so you can have a look at that if you choose to do that. I would like everyone though to have a go at question 3, because this is how it crops up in exams. So this is how they get around the whole thing that I can use my calculator to solve it. They are basically in this question asking you to do exactly what we've been doing, but it's just wrapped up in P's and Q's and all this sort of stuff. So I'm hoping that question 3 is a question you can do, and it is exactly what we've been doing. And then some of you might like to have a look at the challenge here, because this is really what it's all about. This equation here, the equation we used at GCSE to solve quadratic equations, it comes from solving quadratics using completing the square. And so the challenge, which is really hard, so I'm really telling you that now, is for those who really want to have a go at seeing if they can prove the quadratic equation formula. So you're going to do some practice from question 1 or 2. You're all going to have a go at question 3, and then some of you are being brave will have a go at the challenge. And I'm not going to post a solution to that along with this homework, but I will do a solution for it and give it to you next week. I'm a bit sad really, because we've been told to stop setting work on June the 19th, which is sort of effectively when the exams would have finished. So we've only got one more week, 2 more lessons to go. So I look forward to those 2 lessons, and I trust you are all well. Take care.